Water Resources Engineering 2, Unit 1, Gravity Dam. So, it is very difficult to say as where and when the first man-made dam was built. So, archaeological evidences help in estimating that the very first man-made dam is at least 3000 to 5000 years ago. The first modern dam of the world was perhaps constructed on the Nile River in Egypt at Aswan. So, it was completed in 1902 and was a major engineering project. Dams. So, dams may be defined as an obstruction or a barrier built across a stream or a river. So, at the back of this barrier, water gets collected, forming a pool of water, and that will be used for the various purposes such as the drinking water, as well as for the irrigation and the flood control, and also that will be used for the generation of power. Content of this unit, that is the different types of the dam and the site selection for the dam, and the different forces are acting on the gravity dam, and the combination of the load for the design in empty condition as well as in full conditions, and the some mode of failure of the gravity dam, as well as now discuss about the elementary profile, that is also known as the theoretical profile, and means how to convert this theoretical profile into the practical profile, and knowing about the limiting height of the dam. So, that will decide the low dam and high dam, and after that the construction of gravity dam. So, means in the sequence of the construction of the gravity dam, and the at last that will be discuss about the foundation treatment of the gravity dam. A dam is a hydraulic structure constructed across a river to store water on its upstream side. So, it is an impervious barrier put across a natural stream, so that a reservoir is formed. This water is then utilized when it is needed. So, due to construction of the dam, the water level in the river at its upstream side is very much increased, and a large area may be submerged depending upon the water spread of the reservoir so formed. So, dams are constructed for flood control and conservation. So, for the flood control, now the water is stored on the upstream side, and that can be the released under control by using the some spillway gates. So, then this water is the discharge on the downstream side, and this water that can be stored at the downstream side in just downstream side, it will act as a elongated reservoir. So, then it will help to prevent the loss of life as well as some properties due to these floods. And these dams are constructed for the conservation. So, conservation means to save the surplus water during monsoon and to use it when the river supplies are low, or now we can say now this water that can be used whenever it is needed. So, then the conservation may be done for any one or more of the following purpose, that is for the irrigation and generation of hydropower, as well as some water supply and navigation and the fishing, as well as in recreations. So, now here that will shows the some means percentage of the dam is constructed for the conservations. So, now the maximum percentage of the dams are constructed for the irrigation purpose, as well as for after the irrigation, now it will for the generation of the power. So, dam simply that is the impervious structure constructed across the stream. Then the reservoir that will be formed means the water is the stored on one side, that is called the reservoir, and this water that will be discharged over the dam, that is known as the spillway. And the side on which the water get collected, that is called the upstream side, and the other side of the impervious structure, that is called the downstream sides. So, now these are the some different components in the while the constructing of the dam at the stream. The selection of a dam site. So, the selection of a suitable site for the dam, that will depends upon the some factors like, that is the topography. The first factor, that is the topography. So, the river cross section at the dam site should preferably have a narrow gorge to reduce the length of dam. However, the gorge should open out upstream to provide a large basin for a reservoir. So, at the selected site of the dam, the river gorge or gorge should be narrow, so that the length of the dam will be minimum. So, cost of the dam varies directly with its length. Okay. So, such a gorge should, however, open out on upstream side to store the maximum water in the reservoir. And the foundation, the other factor, that is the foundation. So, the site should preferably have good sound rock for foundation. For a concrete or masonry dam, the solid rock at the surface or within a reasonable depth below it. For arch dam, the strong abutment are essential. Rockfill and earthen dams have more flexible foundation requirements, but even in their case, the cost of the dam would be materially affected by the type of foundation is available. Suitable type of the foundation should be available at reasonable depth at the selected site of the proposed dam. The existing foundation conditions may also be improved if required by proper foundation treatment, such as the grouting, etc. The other important factor for the site selection of the dam, that is the spillway site. So, in the case of masonry or the concrete dam, it is not very essential that a good site for spillway available, but in case of earthen dam, it is very essential. So, the best site for dam may be considered to be one where a deep gorge and a flank edge its sides were separated by a hillock higher than the height of dam. So, in that case, the main dam may be located in the deep gorge, while the spillway can be located in the flank. So, the selected dam site should have suitable site for the spillway of sufficient capacity for safe passage of excess floods flow from upstream to downstream. So, now here this is the deep gorge and other this is the some flank, and this flank and the deep gorge is separated by the hillock. So, hillock, that is the higher than the top of the dam, So, main dam is constructed in the deep gorge and the spillway that will be constructed in a flank. So, this is the best site for the earthen dam, best site of the spillway in earthen dam. The other factor, that is the availability and character of materials for the construction. The materials required for a particular type of dam should be available nearby without requiring much of transportation. So, this would very much reduce the cost of construction. For a concrete dam, if natural material or good rock is available for coarse and fine aggregate, it is desirable. So, if the limestone is available nearby, so it may be possible to replace Portland cement partially or fully or wholly. So, earthen dams can be designed to utilize almost any type of materials available at the site through the economy of the work is affected accordingly. So, materials of the construction required for the completions of the dam should be available locally to reduce the cost of its transportation. And the factor, that is the other factor, that is the water tightness of the reservoir. So, the rim of dam should be watertight up to a proposed elevation of the dam. The store water should not be able to escape under the surroundings hills through cavernous rocks or other continuous pervious strata. So, the storage is created by the construction of dam should, as far as possible, be on the impervious strata, and the seepage losses, if any, should be kept to minimum. And the other factor, that is the availability of suitable site for construction facility. So, dam site should offer suitable place for location of colonies, etc. If it would be necessary to connect the dam site to the nearest rail head by a good road, and also if economically feasible by a railway to transport construction machinery and hydro mechanical equipment. So, the selected dam site should be easily accessible from nearby road or rail lines for transportation of men and materials. And the last factor, that is the locality. So, the surroundings near the site should preferably be healthy and free of mosquitoes, etc., as labor and staff colonies have to be constructed near the site. So, the natural environment near the selected dam site should not be disturbed drastically. The entire surroundings near the dam site should be clean and hygienic and free from mosquito travels. So, this is the site selection for the dam. Here, that is the different 7 factors, that is the topography, foundations, spillway site, availability and characters of materials for the construction, water tightness of reservoir, availability of suitable site for construction facilities, and the last, that is the locality. Now, these factors should be considered while the locating of the spillway site, dam site. So, here is a table for the different types of important dams. Now, here now shows the different means types. E means earthen dam, G means gravity dam, A means arch dam, and ER means earth and rock fill dam. So, this is the means here shows the different name of the dam as well as the some year of completions, and the dams are the constructed on the different rivers countries with heights. So, now here the Tehri dam that is shown here means this is the Nurek dam, this is the earthen dam and that will be completed in 1980 on a river of, that is the Baks river in Tajikistan, having the height is the 300, and also shown here this is the Tehri dam, this is the earth and rock fill dam, and that will be completed in the 2002 on a river of Bhagirathi, as well as the height is the 261. So, now these are the some different types, different means dams on different rivers with different height. Classification of dams. Dams which are numerous type may be classified into number of different categories based upon the purpose of classification, such as its use, hydraulic design or material of construction of the structure. So, the first is classification based on its use. So, according to the use, the dams may be classified as storage dam, diversion dams or detention dam. So, the first is storage dam. Now, the storage dams are constructed across the river to store water in the reservoir when there is excess flow in river. This stored water may then be utilized during the period of deficient supply in summer. So, now for example, now the storage dams, that is the gravity dam, earthen dam, arch dam, buttress dam, etc. The other one is the diversion dam. So, a diversion dam simply raise the water level slightly in the river and thus provides head for diverting water into the canal or other conveyance system to the place of use. So, a diversion dam is a smaller height and no reservoir is formed to store this water. So, diversion dams, that is the weir and barrage. Detention dam. Detention dam is constructed to store water during floods and release it gradually at a safe rate when the flood recedes. So, just to trap the sediment and thus to exclude the sediment to flow, that is dike, water spreading dam, debris dam, etc. And sometimes now this detention dam may also be used as a storage dam. The classification based on the hydraulic design. So, based on the hydraulic design, the dams are classified as overflow or non-overflow dam. So, the first is overflow dams. The dam portion which is used for escaping flood waters is called overflow dam. So, its crest level lower than the top of other portion of the dam, like that is the spillway. the non-overflow dams. The dam portion which does not escape flood waters is called non-overflow dams. So, the top of dam is kept at a higher elevation than the maximum expected high flood level. So, water is not permitted to overtop of the dam. So, usually some portion of the length of dam is designed as a overflow, that is the spillway section, which section, and the remaining portions is designed as a non-overflow section. So, a composite dam consists of an overflow masonry or concrete gravity dam joining the dikes of earth fill section. So, this earth fill section, that is the non-overflow dam, and the water is the overflow from the top of dam, that is the spillway. The classification on the basis of construction material. So, depending upon the type of materials of construction, dams are classified as a rigid dams and non-rigid dam. So, the first is rigid dam. The rigid dams are those which are constructed by making use of solid rigid material such as stone masonry, concrete, steel, timber, etc., and are termed as masonry or concrete gravity dam, concrete arch dam, concrete buttress dam, steel or timber dam. So, the Khadagwasla dam in Pune district in Maharashtra is a stone masonry dam, whereas the Bhakra dam in Punjab is a concrete dam. Now, in non-rigid dams, the non-rigid dams are those which are constructed of material such as earth or rock fill without any cementing material and are called the embankment dam, that is earth dam or rock fill dam. So, Tehri dam, that is the Tehri dam in Uttarakhand, that is the earth and rock fill dam. The classification based on size. So, dams may be classified according to size by using the head and gross storage behind the dam. So, the first is gravity dam. A gravity dam has been defined as a structure which is designed in such a way that its own weight resists the external forces. Such dam may be constructed of masonry or concrete. This type of a structure is most durable and solid and require very little maintenance. When the suitable conditions are available, such dams can be constructed up to a great heights. So, the highest gravity dam in the world is Grand Dixence Dam in Switzerland, about the 284 meter, and followed by Bhakra Dam in India. This is the 226 meter. Both are concrete gravity dam. So, the ratio of base width to height of dam in these dams are as far less than the 1:1. So, all major or important gravity dams are now constructed of concrete only, and masonry gravity dams are constructed for only for the small height of dams. So, the advantage of the gravity dams are the gravity dams are relatively more strong and stable than the other, that is the earthen dams. They are particularly suited across gorge having very steep side slopes, and the gravity dams are well adapted for use as an overflow spillway crust. Earth dam cannot be used as overflow dams. Gravity dams can be constructed for any height provided suitable foundations are available to bear the stresses. And highest dams in the world are made of gravity dams only. A gravity dams require the least maintenance, and the failure of gravity dams, if any, is not sudden. It gives enough warning time, and earth dam generally fails suddenly, and they are not affected by very heavy rainfall. So, these are the some advantage of and disadvantage of gravity dam, that these dams are constructed only on sound rock foundation, and they are unsuitable on weak foundation or the permeable foundation. The initial cost of gravity dams always higher than the earthen dams. The gravity dams take more time to construct, and it requires the skilled labor or mechanized plant for its construction. If the height of the dam is raised, so it cannot be done unless the provision for it had been made in construction of lower part of dam. So, these are some different disadvantage as compared to the earthen dams. arch dams. So, an arch dam is a dam curved in plan, carries a major part of its water load transmitted horizontally to the abutment by arch action. The balance of water load is transmitted to foundation by cantilever action. So, the thrust developed by water load carries by arch action. So, it requires strong abutment to resist the arch action. For arch dam constructed, narrow gorge provides natural solution. The arch dams is structurally more efficient than the gravity or buttress dam and result in the reduction of volume of concrete required for its construction. The advantage of arch dam. So, arch dams are particularly adapted to the gorge where the length is small in proportion to height, and for a given height the section of an arch dam is much lesser than a corresponding gravity dam. Hence, the arch dam requires less material and it's therefore it will be the cheaper. In arch dam the width is less, so then the problems of the uplift pressure, that is the very less, and since only a smaller part of water load is transferred to the foundation by the cantilever action, so arch dams can be constructed in moderate foundation where the gravity dams require the sound foundation. So, these are the some advantage of arch dam as compared to the gravity dam. The disadvantage of arch dam, so it requires skilled labor and sophisticated form work. So, the design of arch dam is also this is the quite specialized. The speed of construction is normally slow and it requires very strong abutment of solid rock capable of resisting arch thrust. Hence, it is not suitable in location where the strong abutment are not available. So, these are the some disadvantage of arch dam. So, in our country now here the arch dam is only in one, that is in Kerala, and the name is Idukki Dam. Buttress Dam. An ordinary concrete gravity dam is a solid body of mass concrete, somewhat triangular in section, running across the entire width of the river. Such a solid wall requires huge amount of concrete, which partly remains unstressed to full extent, thereby leading to wastage of concrete. The uplift pressure also acts on the entire width of dam body from its bottom, so which further increase its size without giving any additional benefit as a dam. So, efforts have therefore been made from time to time to effective economy in the use of concrete by cutting down the concrete from those dam portions where it remains unstressed, therefore made to provide hollow gravity dams. So, buttress dam are an improvement over the hollow concrete gravity dam. Therefore, solid walls of specified thickness and section are constructed parallel to flow at some suitable intervals. These walls are called buttresses, and inclined slab or arch slab are then supported on upstream side of these buttresses, and these panels or the flat slabs, that is known as the deck type buttresses. The advantage of buttress dam, the buttress dam is less massive than gravity dams. It can be constructed even on weak foundation on which the gravity dam cannot be supported. The water load acts normal to inclined deck. Hence, the vertical component of the water load stabilize the dam against both overturning as well as sliding. So, the ice pressure is relative importance, since the ice tends to slides over the inclined upstream deck. And powerhouse can be located in between the buttresses, so thus saving the cost of the construction. The amount of concrete used in buttress dam is about 0.3 to 0.5 of the concrete used in gravity dam of the same height. The disadvantage of buttress dam, so skilled labor required and shuttering of concrete ratio are greater than for the solid dams, means at gravity dams, and the deteriorations of the upstream concrete surface has serious effect on the buttress dam with very thin concrete face. So, these are the some disadvantage of buttress dam. So, these are the different types of the dams, that is the gravity dams, arch dams, buttress dam, and the one more that is the earth and rockfill dam that we will discussed in the next presentations. Thank you very much. If you have any problems, you can contact me at any time.